Welcome back again. Let's get out of this class here and continue. So the BP mover is the base class. We have that established, and I'm trying to think of a good way to explain how I'm gonna attack this different from other than actually make a drawing. And here's my super advanced UML diagram editor. It does say paint, but that's an illusion. It's a super advanced tool. This. So I have the BP mover at the top, which has these two interfaces, and we have some event space, we have some limits, and a minimum and maximum delegator stuff. So underneath here, we need to figure out what to put here. And really, we can do two things here, because the objects that we are going to create, or in the end, somewhere down here, the more specialized ones, like a door, a slider, a knob, whatever, all these things, all the way, I'm pointing at my screen, by the way. All the things which is gonna be down here, they are probably gonna be very specific, or they will be very specific. And some of them are gonna be something that can rotate, some of them are gonna be something that can slide. Some of them, in the case of a button, is maybe gonna be something that you can push. And I'm trying to think if there are going to be combinations of all of the above. Something that can move and rotate, but restricted in space. I guess that would be a possibility. So in that case, that is actually interesting. I never thought about that before. Let me think. Because the way things worked in my head, it was either a rotator, or what you would call, probably as a fancy word, a translocator, something that can move, but not both together. But I guess if you need something that can do that, you can create a third class and then do some additional stuff. You can solve this in a number of ways. I realize that, and it's a question of how you want to attack this, really. So I'm thinking as a way of not overcomplicating this completely, because you also have the option to say, do I want my objects to be kinematic, or do I want them to be a physics object? Or do I want them to be able to switch back and forth? Because if I want them to be able to switch back and forth, then I should not create a specialized physics mover, as I'm thinking about doing right now. But if I don't do that, then I will end up having a class that has both kinematic and physics handling in it, where if it's only using one of the two, then I'm going to have a waste of code in there, which may not be a problem, but it's going to be a waste, and it's maybe going to be complicate things a little bit. So it's pros and cons. The thing is, you can always go back and refactor everything if you want to, if you just do it controlled. So I'm thinking that I will split things together, apart. That's what I'm going to do. Physics mover. like this. Nope. So we're going to have a physics mover, and we're also going to have a kinematic, whoops, a kinematic mover as well. So just gonna place these arrows here, something like this. And right now it says physics mover on both of them, I realized. Oh. Okay. So the stuff that I'm gonna start out with is the physics stuff. And I will see if I will ever do a kinematic mover at all. Because the way I want to pick up things, I want to pick up things using primarily using a physics handler, and that's the stuff that I plan on putting in this one. So if I were to make this kinematic mover, I would have to come up with a different way of moving, and actually I probably need to do that anyway at some point. So now I'm just thinking aloud. You know what? Fuck it. I'm not going to split them out. Fuck. Can't decide. I am going to split them out. Oh, that was terrible. BP mover. Physical mover. Okay. So what are we going to have in the physical mover? What is going to be interesting about this is that, let me just check if, yeah. Okay, so that is going to be the fact that we're going to have a physics constraint. One of these. Just call it physics constraint. And it's going to constrain, the physics constraint, if you don't know it, is a way to control or create, it says creates a joint that allows you to connect two rigid bodies together. So you're making a joint between two physics objects, basically. So component one is the first rigid body, and the second one is obviously the second one. So in my case, I only have one rigid body, which is going to be the static mesh component. So I'm just going to use, just because it's more logical to me, I'm going to use component 2. So I'm going to type in static mesh component here, and the X motion is set to locked, so that means that it cannot move. If we look at the way the angular limits are set up, it's all set to free. I'm also going to lock all these, so basically this means that static mesh component is locked down, it cannot move. And that's not entirely true, because if you come bashing with a kinematic object, then that's going to override the physics constraint. And we're going to have a look at some of the problems with that and some of the characteristics of using a physics object versus a kinematic object. But for now, we're just going to lock everything down like this. And we're also going to set the static mesh here to be simulating physics, which we can't. We don't have any mesh. So just going to select them 1 by 1 meter cube. So now it's simulating physics. In React, we are actually ready to make a test. So, damn it. Just gonna make sure that it's not touching the ground. So we have an actor in the world now that we can actually do a quick test with. So here it is. I can walk up to it and I can try to grab it, but nothing is happening. That's because I locked it down, so I just forgot about that. For now, let's just set, whoops, let's allow movement on the Z-axis. Let's go over to it again. Whoopsies. What the fuck? This is a physics actor simulating physics. Oh, that's the thing. We don't have any logic yet to pick it up, because we are, of course, we only implemented on grab, but we're not doing anything with it. So really, nothing is happening. So on our physical mover, we could implement. And I'm saying we could because we don't need to, and we should definitely probably override it. I'm just thinking if this is a bad idea. Yeah, this is actually a bad idea. I'm not gonna implement anything about that in here. I'm gonna move on to the next level, which is gonna be here. So we have a physics mover now. So we're gonna make a new layer here. So the physics mover, the functionality that added in was really minimal, because all we did with this was just to add a physics constraint, and we set the static mesh component to simulate physics. And it's not something we can't do otherwhere. But for now, that is actually all we added to this. At a later stage, we might actually... oh, here's a good thing we can add, because most physics objects, both a rotator or a slider thing, can benefit from being able to grab with being grabbed using a physics handle. So we can put the function to do that inside here, so we don't have to implement it to places. That's actually a good thing to do here. Grab physics handle. So we have the physics handle here, the variable that we set in the BP mover here. This is being passed in from the grab actor, I think it was called. So we can say grab component at location with rotation here. And we want to grab the static mesh component, and we want to grab it at a location. And here I'm going to come back to the grab sphere, really, because this is why it gets interesting. Get transform like this. I'm going to connect this one up. So you're going to see me use the grab sphere rather than the motion controller. And the reason for that is that the grab sphere is this collision body that we have on the hand. And if I want to use this for a remote menu, so let's say I have this laser pointer pointing at a menu, I can go into menu mode, and once I do that, then I can offset my grab sphere onto whatever I point at. and once it doesn't hit anything, I'm just going to snap it back to my hand again. That's going to give me the ability to remote control things, physics objects that I point at a distance. It's going to require a little bit more, and there's going to be some restrictions to it because we are going to have a fixed distance with that implementation. So I'm not entirely sure this is the best way to implement it, but it's one way to implement it. And that's how it is with most things. I'm basically just presenting one way of doing things here. So we're going to add also the other function, drop physics handle, which is going to be the same physics handle and calling release component like this. So we're not going to do anything. We're not going to implement a pick up or drop here. Technically, I think that is a bad idea because it's going to put a restraint on how the children objects are going to act. So I prefer not to do it. That's just a design decision I'm making right now. I can leave this out. By the way, you can see it makes a pass through of the event tick to the parent tick because it has some logic. If I remove this, it's still going to do it behind the scene. Nothing is lost by removing it. It's just being shown. So I prefer to just remove things so it's not cluttering up the view. Just be aware when you do this inheritance stuff that you be careful that you call the parent if you implement something or write something and you need to call, we have parent logic happening, you need to call that. We can get back to that anyway in a moment. So let's get back to the drawing here, and I may name something here as fancy as a BP translocator. And this is the part where I may go a little bit overboard with this because it's basically all it's doing is to add in the damping because no, wait a minute, I have a better idea. I got a better idea. I'm not going to do that. I'm not going to do that. I just had an idea. We're not going to do a translocator. That's going to be a waste of an object here. Yeah. Waste of an object. Not going to do it. We are going to do something different. We have the BP mover, we have the physical mover, and then we're going to create a blueprint child of that and call this BP physical slider. Yeah, physical slider. And if I just needed to do that because mentally I needed to do that before I can go back. The physical mover, we need to do something else. We need to introduce a damping value because physics has a damping, and usually we want to have damping on in order to control the drag and stuff. Damping, yeah. So we have linear damping and angular damping, and depending on if you have a linear constraint on, then you don't want to have you want to have a small linear damping but a very high angular damping usually. So I'm going to set some default values here. I'm going to actually just pump these up to like crazy high, both of them. What? Come on. Okay, like this. So that means that anything like a physical slider here, it's going to have these values here set per default. So since this is a physical slider, as I said, we want to have a different linear damping. So I am going to move all the way back to the mover. Nope, sorry, the physical mover. And I'm going to create a damping value here. I don't want to expose a linear damping or an angular damping. I'm just making this trick here just because I don't want to have two damping values. So I could do that as well. So damping, and this is going to be a setting, and it's going to be public, and it's going to be, what is the limit? Oh, it is public. Okay. And we're going to set a default value of 1. That's going to make, that was the wrong one. Limit, when I said 2, well, 0. So the damping physical linear damping, or depending on the type of physics object. Well, can't really come up with anything better, but hopefully this gives us a clue that this can be both one or the other. Somebody other than me would probably just duplicate these two and expose them or whatever. And now that I think of it, it would probably be the best, really. So, should I just do that? No, I'm not going to do that. I'm sure there's going to be a good reason to keep it here. So I'm going to take this damping value that we have here, and then I'm going to set that onto my static mesh component as a, so this is a physical mover, not this one. So I'm going to move to the physical slider here, and here we're going to set linear damping. Like this. So we're not going to touch the angular damping, which is really high. So that means that when we make our rotator, we're only going to touch the angular damping, and then the linear damping is going to be really high. So that's just the way I decide to do this now. Good. Let's update our drawing with this and give it a name. BP, what did I call it? Physical slider. And maybe you want to type in a few notes. What did I add for this one? I added a physics constraint, and I set it to simulate physics. And this one has physical slider. This one is setting a linear damping for 1. I want to add something else too. Yes, this is where it starts to get a little bit interesting. The physical slider, I think it's a good place to put the pickup or the grab logic. So we're going to find the function override pickup and override drop. These two guys here. So we're going to right click them also and make a call to the parent, and then connect everything up here. Remember, the parent is responsible for doing all the stuff underneath, setting the variables and all that. It's going to be setting them internally, so we don't need to worry about that now. And the physical mover, that's why we implemented these two helper functions, grab, physical handle, and drop. So now we can just use them here. In the case with the physical slider, this is going to be an obvious choice of grabbing things this way. So grab physics handle, call this function like that, and that is all we need to do. On the event drop, we need to do something very similar. That calls to the parent. And here we actually need to be a little bit more careful, because the parent drop here is making use of the physics handle. And since it's going to clear it afterwards, the parent drop here on the mover, here, it's going to clear these variables. Then we need to make sure that the super function is getting called first or last, and then make our drop or release first. Drop physics handle, call this one. So as you can see, the implementation this way becomes very clean, and it's just very convenient for us. So now we should be able to drop a physical slider. It's ugly as fuck, but it should be able to grab. And as you can see, I can grab it, but nothing is happening because I forgot to release it. Let's do that. So this is the physical slider. Let's release it on the Z-axis. What the hell? Okay. You can see I can move it, but I cannot move it other directions, but I can lift it. Okay, so you can think of it as a gate that's going to drop on you. If I had a collision on my head, which I don't really right now, that would be really cool. I'm going to add a collision to the head. So much going to do with that. So we added linear damping to the physical slider, and then we add physics grab, release stuff. One thing I like to do on this one, since we call this a slider, it's implying that it's going to slide in one direction, because we could technically, as I said some time earlier, have a situation where you could have something constrained on a plane. So I'm just going to show how that would work. If we just for now scale things down just a little bit, so it's not so big, and yeah, overwhelming. So we're gonna take the physical slider, and then we're gonna free it on this time on the X and the Y, and lock it on the Z, just for fun. And then where did it go? Here. Then you will see that it's possible to move on a plane. You can see I can move up and down, the hand up and down, but it's going to stay more or less. So I can only move it on one plane now. I can easily see uses for this. Okay, I just thought I saw it back. Okay, never mind. But this is a physical slider. I'm going to keep I'm going to update the definition here and say this is constrained x-axis x-axis constraint. So this is just going to simplify things quite a bit, because we only need to worry about one axis. And then if we need this to slide in a different direction or on a different axis, then we just rotate the thing. So we can use it in different ways that way. So I'm going to find the physics constraint here, and I'm going to set it to, well, here's the thing. If it's we're going to keep everything locked here, but we're going to set the things inside the construction script. So depending on what we have in the settings here, we have a limit here. So if this has a limit, so has limit, then we're going to alter the limits. Did I just talk for half an hour? Okay, great. I'm sorry these videos are getting a little bit longer than usual. I hope it's okay. This boolean here tells us if it has a limit. I'm just going to do this real quick, as fast as I can. And if it has a limit, then we want to set the physics constraint. Oops. Linear x limit to something. And you can choose between free, limited, and locked. So I'm going to set this to limited, because this allows us to give it a limit size, which is for now just going to be the limit here. Okay. The thing is, if we don't have a limit, then we also want to set this to free. So we're going to have this two places here, really. I'm going to set it to free, and then it doesn't really matter what we give it in the limit size here. And I suppose if we run this now, we shouldn't be able to move it, because it's constrained to 0 on, oh well, it is, fuck. Limit 0, oh, god damn it. Okay. Oh, it's limited because, it's not limited because we didn't check this one. Let's try it again. Okay, so now we can't move it. That was what I was hoping for. So I'm going to give it a limit of 100. Now we can move it 100 in that direction and 100 in the other direction. So that is actually an issue. Even though it may not seem like an issue, it is actually kind of a bit of an issue. If we just for a moment select our cube here and turn everything to 1 again, we're going to see the problem here. You can see the green lines here, they represent the distance from the center and to where the center can move to. And I know this box is 1 by 1 by 1. So that means that the distance it can move is actually 2 meters, because it's 1 meter in one direction and 1 meter in the other direction. So the way I've set it up right now with the limit here is actually wrong, because it's actually possible to move 200 centimeters. So the way I'm going to solve this is to multiply this by half, or divide it by 2, depending on how you want to look at it, 0.5. Which is going to be part of the solution. Because now it can only move half the way. And let me just do something. I'm going to dump down another box here, so we can see what is actually going on. I'm going to dump in a box on top of it. And then I'm going to move this to the side. So you can see now it can only move half the distance to one side and half the distance to the other side. But we want it to be able to move 100 centimeters from where it is now, because it's at 0, 0. So the way to solve that is to offset the reference frame, and you can do that by going to the Vent graph and add in a call begin play. And here, remember, now I know we have some stuff on begin play, well, not on the physical mover itself, but we do have something happening on the mover somewhere, don't we? I thought we had something. Well, we will have something eventually. So I'm gonna add a call to the parent anyway, just to be on the safe side. Okay, if things doesn't work, double check that your parent child doesn't have logic that was supposed to execute, and you accidentally missed this this call to the parent. So what we're going to do here is to offset the reference frame. So we're going to drag out the constraint here, physics constraint, set the position, constraint reference position. And this is going to take in a frame 1 and a frame 2. As far as I understand, frame 1 is for the first component of the physics constraint, and frame 2 is for the second one. So since I'm treating this only setting only a constraint on the second component, I'm choosing frame 2. So the reference position you can think of as a relative offset from where it is. So this actually also means that we have some limitations in this design here, which I'm going to talk about probably not in this video, but in the next. But for now, just bear with me and just play along. Okay. So we're going to offset this half the distance back, so that it can only move in the other direction. So we're going to offset this by the limit times minus 0.5. So what we're doing together here is we're setting the limit to only be half what it was supposed to be, which means it's going to be 100 and instead of 2 meters, and then we're going to offset it half that distance to the negative direction. Okay, and what this gives us is something that can now move 1 meter to the side. Whoops. Oh, I have a collision on my hand. That's what is happening. Okay, I gotta fix this. Okay, and then it can move back again. So there we have it. We have almost everything that we need for the most, useful stuff here. Really, that is set up now. Let's see. I think I've talked enough. I'm gonna end the video here by saying thank you for watching. I will be seeing you in the next, hopefully. Bye.